We will use an example to learn how to get the T alpha over 2 critical values, the student T critical values, using a TI-84 calculator. So we have a sample of size 15, and it's a simple random sample from a normally distributed population. We are to find the critical value T alpha over 2 corresponding to a 95% confidence level. Well, let's look at the requirements first. Recall that we either have to have a normally distributed population or a sample size greater than 30, or both. And we have here a sample size less than 30, but we do have the condition of a normally distributed population, so it meets our requirements. We have this 95% confidence level that's given, and that means that we want to be 95% confident that the true mean, the population mean, which is the true mean for this data set, or the true mean for this population that we're interested in, lies in our interval. We want to be 95% confident that the true mean lies in our interval. Okay, so let's see what we know so far. We know that our sample size is 15. So that tells us then that the degrees of freedom that we will need is n minus 1, or 15 minus 1, or 14. Okay, we know that our confidence level is 95%. So that means that alpha must be 5%, or 0.05. So that means then that we're looking for, when we're looking for T alpha over 2 with our degrees of freedom, what we're looking for is T 0.05 over 2, 14, or let's write that more simply, we want T of 0.025, which is 0.05 divided by 2, with the degrees of freedom of 14. Okay, on our calculator then, what we will do, the sequence of key punches, is we need to use the second key, and then we're going to choose distributions, which is, the key itself says VARS on it. And then we will go down the list of distributions until we find inverse T, and then we'll select that. So let's see what that looks like. So it says second key, and see the VARS above it is DISTR. Choose that, and that gives us a list of all these distributions, and then we'll tab down until we find inverse T and enter. Now this one, the display looks like this, where it first asks me for the area and the degrees of freedom, and then I can enter that and it will return a T critical value. Now the area, recall this alpha over 2, this is the area to the right, but what I have to put in here is the area to the left. The easy way to do that, since the total area sums to 1, is for my area to the left to put in 1 minus 0.025, and the calculator will actually do that subtraction and then use this number. Of course, that's 0.9725. You could also do that. Alright, degrees of freedom, n minus 1, we said that's 14. Tab down and enter. Now notice how it gives this to me now. It gives it to me in these parentheses with first the area to the left, comma, degrees of freedom. Some calculators this is what the entry looks like. You actually type in area to the left, comma, and then degrees of freedom. So yours might look a little bit different than mine did, but right here is maybe what yours looks like, where you would type in the parentheses 1 minus 0.025 comma 14, close parentheses. Okay? Alright, so that looks right. It's waiting for me to say, is this what you want? And I say enter, yes. And notice the little thinking that it's doing over here for just a moment. It took just a moment to return 2.14478 for my T critical value. Now, we typically round critical values to 2 decimal places. So I would round this to 2.14. Okay, so what we ended up getting here was 2.14478, which is approximately 2.14. Okay, so recall what we're entering in inverse T. When it says area, it wants area to the left, and what we understand about critical values is this number right here is area to the right, so we had to enter 1 minus. So I'm going to write this down, and then degrees of freedom. So in our case, we put in 1 minus 0.025, comma 14. And that's where we got our 2.14. So practice doing this with your calculator.